3 days ago, a disaster hit the React world as a critical level 10 CVE was disclosed. The CVE calls for immediate updating. So we are going to discuss one, what you need to do, two, what happened, what's affected, how this all works. We're going to look a little bit at the changes that happened and the vulnerability POC. Then we're going to talk about a historical vulnerability that was also a level 10 and how it works. And so at the end, you'll leave with a greater understanding of how vulnerabilities work. So let's get started. First, bleeping computer. Critical React Next.js flaw lets hackers execute code on servers. So first off, this is called react2Shell. It occurs in the React server components, RSC's pre-flight protocol. We'll discuss what all this means. It stems from insecure deserialization, and it was reported by this security researcher, Lachlan Davidson, about a week ago. He found he could achieve remote code execution, so the absolute worst thing that can happen, by sending a specifically crafted HTTP request to RSF endpoints. And it's kind of funny because when I was doing my research, this is part of the morass of React and what it's becoming as they try to make it a kind of seamless full stack experience. I originally researched for React Server Functions. Then I realized it was referencing React Server Components, which seem to be related. I'm not entirely sure. They're listed as separate things in the React documentation, but they all come from the same muddying of the client and server relationship, which we'll discuss. So ultimately, this stems from React and the following packages. It's a very wide-ranging bug. So 39% of all cloud environments where they have some visibility contain an instance of React or Next.js that are vulnerable to this. Comes from a logically insecure deserialization vulnerability where the server fails to properly validate the structure of incoming RSC payloads. There's a validation feature when receiving the malformed data from the attacker, which results in executing privileged JavaScript code in the context of the server. All right, we're going to break that all down. But first, if you have a server running, what should you do? You should immediately apply the updates. And over here, Next.js put out a blog post. I also don't like how much Next.js is becoming almost synonymous with React. I think it's an incestuous relationship that really shouldn't be happening, but it is what it is. So they detail a lot of the same things, React Server Components. We'll talk about what makes things a 10.0. And then they show you the required actions, which are thankfully very simple. It's just upgrading to the latest version. All right, so let's take a look first at what React Server Components are. It's a way of removing a communication call that you would normally have. So here is some normal client code that you would get. You would send this JavaScript to the client, and they would make a call out to your server to get information. Then they would pull the data out of that, they would set up the user, and then ultimately display it in the UI, which makes sense. You can't have user data in the clients, because imagine if you were to ship everyone's user data to every client and it had like my social security number or other vital pieces of information. Anyone could look because they've been delivered that information and everyone else's and see my information. So clearly you have to have the server call and the information has to reside on the server. What React Server Components do though is they kind of hide or muddy this interaction. So what you do is you don't use client. Everything is by default in, this is Next.js we're using here, but the concepts apply more broadly. Everything is a server component by default unless you tell it otherwise. And what that means is it runs on the server. So this will run this fetch user response or request, it'll pull things in, and then it will return this ultimately to the client. And so you skip having to do a client-side request. That's all that it's doing. And you can kind of read the React docs, but I'll be honest, I thought it was pretty poor documentation. All right, so what happened? Well, the researcher, he has published a website where he talks pretty quickly about it, and he's, as time goes on, filling things in. He has included a GitHub repo that has POCs behind it. Unfortunately, he doesn't have a full write-up yet, soon. And so we could go through and we could try to make sense of things. But as you're going to notice, this is a fairly complicated, it seems, exploit. And we will discuss what makes a vulnerability powerful or level 10. Like, how does that work? How does the CVE scale generally work? And you have a number of different factors that are taken into account. So one is the number of targets. And as we just said, about 39% of a massive user base is vulnerable to this attack. So there are a lot of targets. The reliability of the exploit, how hard is it? Sometimes you'll get things where it's like dirty cow for Linux. Cow stands for copy on write. It's a race condition where you spawn a whole bunch of different threads, as I understand it, and then eventually you can get a bit flip, and that bit flip might give you privilege on the server, or it might crash the server. So dirty cow, as an example, which let's just quickly, it's a very fun image. Here we go. The dirty cow image is a fairly unreliable exploit, but it's worth trying. This one sounds like it's about 100%. And moreover, it doesn't seem all that hard. It seems complicated in that you have to understand the deserialization logic, which I don't. But if you knew it, this does not seem super involved. This being, I've already closed it, but the POC. Third, the degree of control provided. So you could get everything from, hey, you can read something you're not supposed to read, but it's limited, all the way to full server control. And in this case, we have full server control, so very high degree of control. It's an unauthenticated means of connecting to it. So it's one thing if you need to be connected or physically there, like in front of the terminal, or to have a client login. It's another thing if it's network-based and it's unauthenticated. That means anyone can do anything they want, potentially. You can just scan servers, find that it's running React, and then you can try the payload. So getting back to it, this is what I thought was, yeah, it looks involved. I wouldn't be able to read this initially, but it's all of 65 lines to make this happen. So it doesn't seem all that complicated to me. We could look. So I'm here on the Facebook releases page. We know this all happened 3 days ago. And so we could go through the diffs. And I guarantee you that attackers are right now, if they're not just using the POC out of the box. But we could look at, this was the first of the releases. And we can see here, this has to do with the pre-flight, fixing it. And we could read through these diffs, including this very large one right down here. This is a 900-line file. I would rather not try to understand this because, frankly, I don't care that much about React. I'll wait for the guy's write-up in just a little bit. Instead, what I'd like to do is I would like to examine with you kind of the range of different complexities that are present in vulnerabilities. I would say they tend to be on two ends of the spectrum. So one is incredibly dumb you can barely believe that someone was able to overlook this, put this in, and then on the far right side, it's Gigabrain. No one would ever discover this. This is Rain Man working in MIT in a basement somewhere. It just an incredible degree of complexity and understanding of the machine. So we are going to look at Log4Shell, which is a vulnerability from about 5 years ago, and we're going to compare it. And the reason we're going to compare it is because they're very similar. They're both network-based vulnerabilities. They have a lot of targets, and they both work with a very high percentage probability and allow full control. So let's take a look at Log4Shell, and then I'll run through what it would take to actually exploit. So this came out. This is back in November of 2021. It was given a 10, the highest available vulnerability score. It occurs because of Log4j, and it was almost immediately actively being exploited. So they found that that networks were being probed globally, so many people were scanning, and they were trying to actively exploit it. This is a much nicer way of viewing how the attack works. So you have an adversary, and you have over here a victim server. The adversary is going to send this specially crafted user agent string. And what that's going to do is when that string is logged to Log4j, Log4j incredibly will execute code. So this is not hacking, or, I mean, it is hacking, but if somebody leaves the door wide open and you walk in, have you done a breaking and entering? Have you robbed the place? I mean, yes, probably in the eyes of the law, 100%. But there's a difference between Mission Impossible or Ocean's 11 and just some guy walking in through a closed door. And this is essentially through an open door. This is an open door. So here we see Log4j would parse the string query, and then it would send the code, and it would execute. All right, so what would this look like? I am going to go to Google, because you may not know, for example, what a user agent string is or what any of those terms mean. So let's open up DevTools, and let's watch what happens. When you hit a website, you make a network request for it. In this case, I'm making a GET request for google.com. If we click into it, what we're going to see here is we see the request, and we see that the response had headers, and our request also had headers. So for example, we said we'd accept gzip, that we're using English. We pass a cookie so it knows who I am. You can see I'm logged in up here. And then at the very bottom, we have a user agent string. So a header is it's an arbitrary key value. So you can pass any header you'd like. There are some standard ones, though, like user agent or cookie, that everyone expects because they've been just agreed upon. I will always pass this, and you'll look for this in the connections. So let's copy this out as a curl, and then I will paste it. Curl is a network utility that lets you make requests, and let's break this down. So we're making a request to Google, we're allowing it to be compressed, and then all those -h's that you see, those are different headers that we're adding. So we add a header here, and the key is what comes before the colon, and then after the colon is the value. So for example, I'm using LibreWolf, which is a Firefox variant. So I'm saying this is Mozilla 5.0 Firefox. Cool. So all we would need to do to be our elite hacker man is go in here and change this to be that special string that we saw that started with JNDI : and we would direct it to a server that we have stood up that would then deliver the payload. Now, this won't work because this is a vulnerability from 5 years ago. We don't even know what Google is actually using on their server. But you can see this is not a sophisticated attack by any means. And let me show you what some attack code might look like. So we need to deliver Java code here. So I have attack.java, which if I wanted to serve up, I could easily start up a Python server on port 999. Actually, let's go. Okay. So localhost 9999. Then we see our attack.java. Yes, I would have to make myself available to the internet, which I could do with something like ngrok if I wanted to. But let's just take this to be good enough. And let's look at what my attack could do, potentially. I am going to use the Java process method, and I am going to run on what I'm assuming is going to be a Linux machine. So I'm going to try to do a bash command. And as a super user, I am going to remove all the files from the machine. Obviously, this is a very simple way just to do like maximum destruction and everything else. You could do more complicated things, like you could return a shell to yourself. You could try to exfiltrate data from their server. You could do all kinds of things. But the point is, this is an incredibly simple way to exploit something, and it's certainly way more on the leftmost side of the complexity scale. And I would guess that this React thing is more towards the right, maybe more middle. We'll have to see as we go. Anyway, and how does this arise, I guess? It arises from a concept called weird machines, which is whenever you have any kind of complicated execution environment, like a computer is, you end up with many submachines that can actually happen as a result. And you may not even know all the things that can be done on a given server because there are all kinds of unintended consequences. And we've got this beautiful, it's probably MC Escher, where you can see all the different forms of the man over the distance. As an example of a weird machine, if you've ever heard of buffer overflows, which I'm not going to explain now and I'm not going to get into, but a buffer overflow is an incredibly common way of hacking machines. And over time, the defenses have gotten to be much greater. The attacks have had to evolve in line. And so we've come up with increasingly ingenious ways to trick the machine, given what's already there and already present, into doing what we want it to do, given the operations we have, which the defender never anticipated. So it's a very cool space. All right, bottom line, update all of your React and Next.js applications and stay safe out there. Thanks. Later.